Good morning, guys. To get back into the roll of classes, we're going to begin 8.3 today. Now, the first half is very simple. The second half is not that simple, but today it's a very easy class, about literally 8 minutes. That simple. Today we're going to look at three things: the dot product of two vectors, the magnitude of a single vector, and also how to calculate the angle between non-zero vectors. Okay, you have to have at least two actual vectors, no non-zero vectors. Now, first of all, the dot product. And this is on page 501. Let's say they give you vector A, which is 3, 6, and vector B, which is -4, 2. And they ask you two things. They ask you, give me the dot product of these two vectors, and also, are they orthogonal? Which is another way of saying, are they perpendicular, or do they create a 90-degree angle between them? Now, all we have to do is use this very simple formula. We multiply A1 times B1, then we add it to B1 times, A2 times B2. So again, let's begin. Let's multiply A1 times B1. 3 times -4 is -12. Plus, now we multiply B1 times B2. B1 times B2 also gives me 12. Now, when the dot product gives you a 0, that means you're actually looking at orthogonal or perpendicular vectors. So questions might come up saying, are these two vectors perpendicular? All you have to do is use this formula, see if you get 0, and then that means they are. If you get a non-zero value, that means that they are not perpendicular. Let's calculate the dot product of two other vectors. Let's say they give me 2, 5, and also B would be 8, 4. The dot product, which is this denoted AB, pretty much again, let's begin. A1 times B1 gives me 16 plus A2 times B2 gives me 20. I end up with 36. That is a non-zero number. That means these two vectors are not perpendicular. That's it for dot product. Pretty straightforward, pretty simple. And one thing to note, you need to know these two because the last one is just pretty much almost a combination of the previous two. Now, we're going to calculate the magnitude of a vector. Now, we actually use dot product, but only with a single vector. So we're kind of like multiplying that vector times itself and then doing the square root of it. So on page 501, again at the bottom, they're asking me, please calculate the magnitude of this vector of A. All you have to do again to calculate the magnitude of A is square root of A times A, which is the same thing as saying the square root of the distributed values. -5 squared plus 12 squared. Again, 25, 144, you add that to the square root and you end up with 13. You can try that at home. Remember to properly distribute the numbers, okay? So remember, you don't, ¿cómo te digo? Just, again, you distribute the square and then you plug them into your calculator and you're pretty much done. That would be example 2 of 8.3. Multiply that by itself and then, perdón, una cosa. See, I know it wasn't making mathematical sense. I apologize. There is no plus symbol here because we're dealing with vectors, not additions. Okay, we multiply these two vectors, or that vector times itself, and that is pretty much the square of the first plus the square of the second, within a square root. So you're not actually doing a distributive property because, you can't distribute within a vector per se, but you just square the first and square the second. Think about it. I mentioned in the beginning that it was kind of using the dot product. You multiply a1 times b1, which is -5 squared, plus a2 times b2, which is 12 squared. So again, the magnitude of a vector is pretty much the dot product of that vector within a square root. And you're done. You repeat the vector twice, of course. This times this, plus this times this. Solve it. That gives you the magnitude of vector A. You don't have to do anything else. That's simple. Now, to finish today's class, we're going to go over the angle between vectors. Now, if you look at the explanation in the book, I'm not going to draw it. We always use cosine. We always use cosine pretty much. And what you do is, let's try doing example 3a. They give me these two vectors. They give me vector A. They give me vector u, which is, let me just change my marker. I apologize. Here we go. They give me vector u, which is 6, 2, and they also give me vector v, which is -4, 3. Now let's go over this particular formula. All we're gonna do at the top, is do the dot product. 6 times -4 plus 2 times 3. That's all we have to do there at the top. Now at the bottom, we're going to do the magnitude of A. Now let's do it pretty much in our brains. Let's see here. We have 6 squared is 36, 2 squared is 4. When we add that and put it within a square root, we end up with this. Times the square root of the magnitude of the second vector. -4 squared is 16, 3 squared is 9. We add those, we get 25 and put that in a square root. Now, and again, remember, this is times, not x, okay? Now let's just go ahead and simplify all this. Cosine theta equals 24 plus 6 gives me 30. Now we can simplify these roots. Square root of 25 is 5, and square root of 40 is the same thing as square root of 4 times 2 times 5, 8 times 5. We can send the 4 out of the radical as a 2, multiplies my 5, so I actually end up with 10 radical, what's left inside the parentheses, 10. In the book, you end up with 5 radical 10. Let me confirm. 5. There's a small mistake there in the book, because again, this becomes a 5. I simplify this. I send the 4 outside. I'm left with a 10. So there's a small mistake there. That's the actual answer. That's all you have to do pretty much. And also, if you actually want to find the angle, again, we're given the ratio. We're given the ratio. To find angles, we use the inverse. To find angles, we use inverse. You write this expression in your calculator, select inverse of cosine, boom, make sure your calculator is set to degrees, and you're gonna get the angle. That's pretty much it, pretty straightforward, pretty simple. If you do have questions, please let me know. Now the homework is from page, shouldn't take you very long, from page 506, do 1 through 4, which is pretty much dot product, 10 to 11, which is pretty much two magnitudes, and 16 through 17, which is pretty much finding the angle between those two non-zero vectors. If you have questions, let me know. We're gonna go, just so you guys know, for the rest of the year, we're gonna do a little bit more of vectors. We're gonna do an exam, and then we're definitely gonna give limits and derivatives, because that's really gonna help you next year. So that's definitely gonna be given. And we'll see about sequences and series, maybe, and a project to end the class. So you can expect the last 2 weeks of class or week and a half to just be a project. So you can expect maybe 2 more weeks of class, 2 more exams within those 2 weeks, and a project to finish the school year. Most of you guys have been doing pretty well. I want you all to confirm the daily work you've been sending. Since most of the grades will be the actual daily work, I'm giving you the chance to send your daily work at a very small penalty, incredibly small penalty. We're being flexible because the situation is very difficult for everybody. So if you haven't done your work, your daily work, send it today, send it tomorrow, send it as soon as possible. It will be a very small penalty, but believe me, it's better than getting no grade for the weekly work, which is most of where the grade will come from. Please don't ask me, Profe, can you tell me which days I'm missing? No, you have to actually, I'm giving you the chance to check every daily post. If you didn't do the homework, send it in. I'm giving you a chance. Believe me, you're all going to end up with a very good grade if you just do the daily work and do decent on the exams, because I expect everybody to get a 100 in the project. That's the expectation. And that's pretty much it. Pretty simple, straightforward class. A little bit of homework. If you have any questions, let me know. Take care, guys.